Hello dear students. In this session we'll learn about the design of post tension slab. Okay. What do you mean by post tension slab? In this post tension slabs we are going to apply the pre-stress before the concreting. Okay. So let us see one way slab and two way slab. This is classification of slab. This is one way slab and two way slab. One way slab first we'll see and then we'll go for two-way slab. Okay, so one-way slab is, so here we'll go for one-way slab. So design of pre-stressed concrete one-way slab based on principle of designing members for flexure. Okay, here we are going to design, or we are going to focus on the flexure part in one-way slab. Okay, one-way slab may be supported across the entire width of slab by beams, piers, abutment or bearing walls which are positioned perpendicular to the longitudinal axis of span, or the supports may be at an angle to the span directions. So where we required larger space area at the top, that is at the slab. Okay, so one way slab are supported on beams, piers, abutments or bearing walls, and these are positioned perpendicular to the longitudinal axis of span. Okay, so this is very important. Just remember, the spans and supports are perpendicular to each other. One way slab may be continuous over one or several supports. One way slab may be continuous over one or several supports. So it can be one span slab, or it can be a continuous slab as 2-3 spans. Okay, the pre-stressing force and eccentricity of cable required at prominent section to resist dead load and live load movements are determined. So first we are going to calculate pre-stressing force, eccentricity of the cable at the prominent sections to resist the dead load and live load movements. Okay, are determined, and spacing of cables fixed based on the availability of type of tendons. Okay, so this is very basic steps that we have studied in the design of reinforced slab. So first we'll calculate total force, then eccentricity. Here we require eccentricity for the tendon part. Okay, there is a pre-stress force, and because of that pre-stress force we have to locate the eccentricity in such a way that it will resist the dead load and live loads. And then we'll calculate the spacing of the cables or number of wires or tendons required, and will accordingly provide the reinforcement. Will accordingly provide the pre-stressing. Okay, so this is the basic idea behind the design of one-way slab. Okay, now we'll go for design steps for post tension slab. This is very important part, and just remember everything is there in the IS code. Again and again I am repeating this thing. Just you have to go for it, and just you have to be familiar with the IS code. Then we'll first of all we'll see the design of one way slab, and then we'll go for numerical. So design steps for one way post tension slab. PT means post tension slab. First step is, obviously we have to calculate the loads. Okay, according to that load we'll calculate the moments, and we'll calculate the spacing of tendons, etc. Then determination of live load and dead load movements. MQ is a mg is the dead load moment, and that is calculated as WL square by 8. Here MQ, Q is for live load, and G is for dead load. Okay, so WL square by 8, it will act as a UDL. So maximum bending moment for UDL case is WL square by 8. Okay, then determination of range stress. Okay, here there are FBR and FTR. These are the stresses at top and bottom fibers. So accordingly we'll calculate these stresses. and by stresses we calculate the pre-stressing force. Okay, so and range stresses means what? We are going to locate the eccentricity. So why we are going to locate the eccentricity? Because we are going to apply the tendons. Okay, the tendons will sag after we disconnect, or after we cut the tendons, after applying the calculated amount of pre-stress. It will at a one time or at one phase it will go sag, or it will undergo the eccentricity. So we have to plan for that eccentricity. Okay, uh, to keep the structure stable, we are allowing the eccentricity, or and we are locating the eccentricity in the safe zone. Okay, so that's why we'll calculate this range stresses, and according to this range stresses we will calculate the pre-stressing force and then eccentricity. So I'll explain the steps one by one. So just keep in mind that we are going to design the post tension slab. So we are going to apply the calculated or quantified amount of pre-stressing force, and because of that pre-stressing force it will that tendons will undergo eccentricity. So main uh, motto of our design is determination of pre-stressing force and then eccentricity. Uh, if any stresses are larger than the allowable stresses, then we'll go for the design, or we'll go for that particular spacing tendons वगैरह. Okay, so determination of range stress is, so FBR is equals to eta FCT minus FCW. Just remember these signs. I will explain what is the meaning of each and every subscript part. Okay, and FTR is equals to FCW minus eta FU. Now just uh, look at this part. I have written for your simple understanding. FBR means what F stands for? It is stress, B for bottom, and R is for range stress. So range stress at the top fiber, or range stress at the bottom fiber. So FBR is range, R is for range stress, F is for stress, and B for bottom. Okay, so range stress at the bottom fiber, and FTR is, F is for stress, T for top part, and R is for range stress. So range stress at the top part. Okay, top fibers. Okay, this is the simplification of this symbols. So these are the FTR and FBR are the range stresses at top and bottom fibers. Eta or efficiency, or you can easily say it as loss ratio or reduction factor for loss of pre-stress. FCW, now here F is for stress, C is for compressive stress, and W is for under service load. Okay, so FCW is the allowable compressive stress in concrete under service load. FU is the tensile stress. FCT is the allowable compressive stress in concrete at initial transfer of the pre-stress. Now here I have explain what is the FCW and FCT part. Okay, FCW, F is for stress, C is for compressible, and W is for allowable. Okay, now FCT is the, F is for stress, C is for compressive, and T is for transfer. So just in this way, just remember the symbols. It will be easy for your calculations. Okay, then here we have calculated these range stresses at top and bottom fiber. Now what do you mean by top and bottom fiber? Just so suppose this is the slab, span of the slab. Okay, sorry, this is slab. Okay, span of the slab, and it will have particular amount of thickness. Okay, by looking from the thickness part. Okay, just as a this is the T thickness. Okay, thickness or depth of the slab. So these are the stresses at the top fiber and these are the stresses at bottom fiber. So we have calculated these stresses. Okay, the stresses in top and bottom and middle of the part are very different. That's why we have calculated separately for top and for bottom. Okay, then determination of thickness of slab. Okay, in the reinforced slab we focus on the depth of the slab. Okay, we calculate the depth of the slab. This is very important part. So here we calculate the thickness of slab, that is Z is equals to BH square upon 6. Now here we actually doesn't know what is the meaning of these terms. That is we know the width, will take it as a 1000 meter, sorry, 1 meter 1000 mm, and we doesn't know what is the total depth of the slab h. So that's why we know the moments and we know the stresses at the top and bottom fiber till now. So that's why we'll use this formula to calculate the thickness of the slab. Okay, and this will by using this formula we'll arrive at the accurate value. Okay, so it is mq plus 1 minus loss ratio into mg divided by fbr. So this is the formula for determination of thickness of slab. Then determination of prestress in concrete as top of the section and bottom of the section. Now we have calculated stresses in the step number 2, top and bottom fiber. Okay, so now here calculate the pre-stress amount of pre-stressing force at top and at bottom. Okay, so this is the formula for calculation of pre-stress in concrete at top and bottom of the sections. Okay, now we'll arrive at the main part, that is determination of pre-stressing force. Here we have calculated pre-stressing force P is equals to, we calculate, how do we calculate the force? Okay, it is the stress divided by area. Similarly, sorry, the stress into area. Okay, stress is load divided by area. Now here we are going to calculate the load, that is pre-stressing force. So we will multiply stress into area. So this is the way we calculated. We calculate P is equals to A by 2 F SUP. SUP is the pre-stress in concrete at top and bottom of the section. Okay, plus FINT internal, and this way we'll calculate the pre-stressing force. Then we'll calculate the centricity. It is E is equals to Z by A. We know this formula. Okay, we have used this formula very frequently. It is Z by A F int plus minus f sup divided by f int plus f sup. Okay, so it will end our numerical it will complete our the design steps for the one way slab post tension. Okay, so in the next lecture we'll go for numerical and we'll complete our second unit. Okay, we have to calculate a two-way slab, uh, reinforcement of two-way slab, that is very in parallel, it is very much similar or it is in parallel way as a one-way slab. So there are minute changes in design of two-way slab. So we'll study that part also in the next session and we'll conclude our unit. Okay, so if you have any doubts regarding this designing part, so then just directly message me or directly contact me. Okay, thank you.